Okay, so you're going to memorize all 6 of those guys. You have to have them memorized. They're not going to go away. Now we're just going to use them. And the thing we want to remember is that we've just added 6 small pieces of information to everything else that we already know. You're going to use your other basic rules. Now you have 6 really small pieces of information that you just memorize and use them when you need them. So this guy right here, we're going to have 2 of our new pieces of information, but then we've got some old stuff. So do what you would do normally, which is this guy right here. I would do some rewriting. So I'm going to do a little rewriting first. That's going to be 2/5 x to the negative 3 minus 5x squared plus 4e to the x. That is still the original, but in a more calculus-friendly format. And now I'm ready to take the derivatives. Okay, there are going to be a whole bunch of people that make this problem so much harder than it has to be. These guys right here are just coefficients. You do not need a product rule for coefficients. Just write them down. One of our basic rules was that coefficients, numeric coefficients, just kind of hang out, that you don't need to really worry about them. But after I teach people the product rule, they start doing the product rule all the time. And it wouldn't be wrong to do the product rule here. It's just overkill. And invariably, people that use the product rule on coefficients do the product rule wrong. You don't need it. So my derivative, just write that 2 down. So 2, derivative cosecant is negative cosecant x, cotangent x. Just write that 3 down. The derivative of secant is secant x, tangent x. And we'll show all the steps here. I don't know. We're showing all the steps, but not many. I was going to separately multiply by 3, but I think we can go ahead and multiply by 3 here. 2/5 times negative 3 is going to give me negative 6/5. X to negative 4, multiply by the exponent, decrease the exponent by 1. Then minus 10x, and then the same thing here. That 4 is just a coefficient. You do not need a product rule for coefficients. And so just write the coefficient down, and the derivative of e to the x is e to the x, and let's make this look just a little bit prettier. Get rid of those parentheses that I don't really need. Then if you wanted to, you could drop that guy down. So negative 6 over 5x to the 4th minus 10x plus 4 e to the x. And so again, the point, just 2 pieces of information put in with everything else that we already know to do. Okay, next one. I'm just going to write this a little bit bigger. I got 2x times tangent x. It's a product, and so I have to use the product rule. There is no choice here. So doing the product rule, plane first, derivative of the second, plus plane second, derivative of the first. Product rule. Plane first, derivative second, plane second, derivative first. You do not have to show that step. I will keep showing that step till I think people know the product rule. Now actually doing it. Plane first, leave it alone. Derivative tangent x is secant squared x. Plane second, leave it alone. Derivative 2x, 2. And then all we really would do to simplify this is that 2 is going to look prettier in front of the tangent than behind. please note, it did not become tangent to x. Your arguments, your angles, or your trig functions are not going to change unless you do some trigonometry. Over here, this angle, this argument of x plus h did change because we did trigonometry. Over here, you're not doing trigonometry. This is tangent x times the number 2, not trig. And so that means that x doesn't change. The angles, the arguments of your trig functions are not going to change unless you do some trigonometry to them, unless you do a trig identity to actually change them. You do a double angle identity, a half angle identity, angle addition, angle subtraction identities. They can change arguments. They can change angles. Multiplying by 2 is not trigonometry, so it doesn't change that angle. And so whenever you do a calculus problem, do a quick check. My angle was initially x. So that means all my trig functions have to have angles of x, arguments of x, unless I did trigonometry. I didn't do any trigonometry. I only did trigonometry, or I only did calculus and multiplication. No trigonometry, so the angle of x stays the angle of the x. Now the trig functions changed because of the calculus, but the angles do not change. Your angles do not change in your trigonometry. Your arguments in your trigonometry do not change if all you've done is algebra and calculus. Okay, let's go on to the next one. Okay, again, another product rule. So using the product rule, plane first, derivative of the second, plus plane second, derivative of the first. Plane first, derivative second, plane second, derivative first. And again, you do not have to show that step when you're doing the product rule. And so that's going to be cos next, then derivative cotangent, you will memorize it, negative cosecant squared. Then I have plane second cotangent, derivative of cosine x minus sine x. And there is my unsimplified derivative. Now, when there's simple trig that can simplify, that's what we're going to do. Now, first, let me just do a little rewriting, moving those negatives up to the front. They'll be a little prettier there. Okay, so one thing, and we'll talk about this when I get the problem done. There is some basic trigonometry right here that I honestly would expect, which is this, that cotangent is cosine, just lost my train of thought there for a minute, cosine over sine. And so once I recognize that, I get some very good canceling going on. And now I have cosine x times, or negative cosine x times cosecant squared x minus cosine x. And there would be a good enough answer for me. You've done some very basic trigonometry. That's good enough. But I want to show you other things that might happen. You've done the basic trig there, and I do really expect everyone to see cotangent and really immediately remember, oh, cotangent is cosine over sine, those things are going to cancel. But now some other stuff you could do, but don't need to. Notice I could take out a cosine x, or negative cosine x. And that'd give me cosecant squared x plus 1. You could do that if you wanted to. And then there are also other games we could play. You could recall that 1 plus cotangent squared is cosecant squared, or that's cosecant squared x minus 1 equals cotangent squared x. You could do that. So, that one you should know. Everyone should know it's one of the basic Pythagorean identities. So you could say, yeah, I remember that 1 plus cotangent squared x is cosecant squared x. And then just rewriting that a little bit, subtracting the 1 to the other side, we'd have cosecant squared x minus 1. Then we could apply that there. Actually, I don't know why I wrote that. That's true, but pretend I didn't see it. Pretend I didn't write that there. That's all true, but let's pretend it didn't happen because I don't need it. So then cosecant squared is that, so I could say 1 plus cotangent squared x plus 1. Didn't put my 1 in there. And so then I could have negative cosine x is 2 plus cotangent squared x. And there are other things I could keep playing with it. My point here is that the trig answer is that there can be lots of different trig answers. Up here, this answer right here, perfectly good. My guess is my lab math would have that answer. Don't care. If my lab math did this and you didn't do it, and you didn't think to factor it, just write me, I can adjust your score. But there are other things you can do. And so that's the thing you always have to be mindful of when it comes to trig answers. Your answer may be perfectly true and correct, but it can look different than the other answer because of various trig identities applied. Like I said, here's the good enough answer. Now, if do I have the right answer? Do I not? It looks different, but it could be the same because it's trigonometry. Quick check. Put a number into your answer. Put a number into the computer's answer. And if you get the same result, it is probably the same answer. Probably. Maybe you pick the one number where the two expressions happen to be equal, so it's not a perfect check, but it's probably the same answer. A better check, but takes longer. Graph your answer. Graph the computer's answer. Same graph, same answer. But I do expect basic trigonometry, so I would expect that answer. I would expect this answer here. I do expect basic trig. Okay, we will conclude that lecture.